The National Electrical Code, or NEC, does address the placement of ground rods in relation to single-family dwellings. Specifically, NEC Section 250.52a mandates that a ground rod electrode must be installed at a minimum distance of 6 feet away from any part of a single-family dwelling. The purpose of this requirement is multifaceted, encompassing both safety and practical considerations. From a safety perspective, maintaining a separation between the ground rod and the dwelling minimizes the risk of stray voltages or fault currents from affecting the building's structure or occupants. In the event of an electrical fault, the ground rod provides a low impedance path for current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. Placing the ground rod too close to the building could potentially increase the risk of current flowing through the building's grounding system or even into the soil surrounding the foundation, creating a dangerous situation. Furthermore, the 6-foot distance helps to prevent physical damage to the building's foundation or underground utilities during the installation or maintenance of the ground rod. Driving a ground rod requires a certain amount of force, and doing so too close to the foundation could potentially cause cracks or other structural damage. Similarly, there may be underground pipes, cables, or other utilities buried near the building's foundation, and maintaining a safe distance helps to avoid accidentally hitting or damaging these utilities. The 6-foot requirement also facilitates easier access for inspection and maintenance of the grounding electrode system. Over time, ground rods can corrode or become damaged, and it may be necessary to replace or repair them. Having adequate space around the ground rod makes it easier for electricians or other qualified personnel to access and work on the grounding electrode system without having to disturb the building's structure or landscaping. It's important to note that the 6-foot distance is a minimum requirement, and in some cases, it may be necessary to place the ground rod further away from the dwelling. For example, if there are underground utilities or other obstructions that prevent the ground rod from being installed at the required distance, it may be necessary to relocate it to a more suitable location. Additionally, local codes or regulations may impose stricter requirements for ground rod placement, so it's always important to check with the local authorities to ensure compliance. The NEC also specifies requirements for the type and size of ground rods that must be used. Ground rods must be made of approved materials, such as copper or galvanized steel, and they must be at least 8 feet long and 5/8 inch in diameter. The ground rod must be driven into the ground until at least 8 feet of its length is in contact with the soil. If bedrock or other obstructions prevent the ground rod from being driven to the required depth, it may be laid horizontally in a trench that is at least 30 inches deep. In addition to the ground rod, the NEC also requires that a grounding electrode conductor be used to connect the ground rod to the building's grounding system. The grounding electrode conductor must be sized according to NEC Table 250.66, based on the size of the service entrance conductors. The grounding electrode conductor must be securely connected to the ground rod using an approved connector. It is critical that you never take shortcuts or deviate from the NEC requirements for ground rod placement or installation, as doing so could compromise the safety and effectiveness of the grounding system. A properly installed grounding system is essential for protecting people and property from electrical shock hazards and for ensuring the reliable operation of electrical equipment. In areas with corrosive soils, it may be necessary to use ground rods made of more corrosion-resistant materials, such as stainless steel or copper-clad steel. The NEC also allows the use of other types of grounded electrodes, such as ground plates or ground rings, under certain conditions. Ground plates must have a surface area of at least 2 square feet and must be buried at least 30 inches below the surface of the earth. Ground rings must be encircling the building or structure and must be buried at a depth of at least 30 inches. The size of the grounding electrode conductor for ground plates and ground rings must be determined according to NEC Table 250.66. When multiple grounding electrodes are installed, they must be bonded together to form a single grounding electrode system. This bonding ensures that all grounding electrodes are at the same potential, which helps to minimize the risk of voltage differences and electrical shock hazards. The bonding conductor must be sized according to NEC Table 250.66 and must be securely connected to each grounding electrode using approved connectors. The NEC also specifies requirements for the protection of grounding electrode conductors from physical damage. Grounding electrode conductors that are exposed to physical damage must be protected by rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved means. The protection must extend from the point where the grounding electrode conductor enters the building to a point at least 8 feet above grade. In addition to the requirements for ground rod placement and installation, the NEC also includes requirements for the inspection and testing of grounding electrode systems. Grounding electrode systems must be inspected and tested periodically to ensure that they are functioning properly. The inspection should include a visual examination of the ground rods, grounding electrode conductors, and connections to ensure that they are in good condition and free from corrosion or damage. The testing should include a measurement of the grounding electrode resistance to ensure that it is within acceptable limits. A low grounding electrode resistance is essential for providing a lower impedance path for fault current to flow back to the source. The NEC recommends a grounding electrode resistance of 25 ohms or less. If the grounding electrode resistance is higher than 25 ohms, it may be necessary to install additional grounding electrodes or to improve the soil conductivity around the existing grounding electrodes. Soil conductivity can be improved by adding water or by treating the soil with chemicals. However, it is important to use caution when treating the soil with chemicals, as some chemicals can be harmful to the environment. In some cases, it may be necessary to consult with a qualified engineer or electrician to determine the best way to improve the grounding electrode resistance. Proper grounding is a critical component of electrical safety, and it is essential to follow the NEC requirements for ground rod placement and installation. By understanding and complying with these requirements, you can help to protect people and property from electrical shock hazards and ensure the reliable operation of electrical equipment. Grounding is a fundamental concept in electrical engineering and safety. It provides a low impedance path for fault currents to return to the source, thereby tripping over current protection devices like circuit breakers or fuses. This rapid clearing of faults minimizes the risk of electrical shock and fire hazards. A ground rod is a common type of grounding electrode, typically made of copper or copper-clad steel. It is driven into the earth to establish a direct connection to ground. The effectiveness of a ground rod depends on several factors, including the soil resistivity, the depth of the rod, and the number of rods installed. Soil resistivity varies depending on the type of soil, its moisture content, and its temperature. Generally, soils with high moisture content and high mineral content have lower resistivity. The deeper a ground rod is driven, the lower its resistance to ground will be. This is because the deeper soil layers tend to be more stable in terms of moisture content and temperature. In some cases, a single ground rod may not be sufficient to achieve the desired grounding resistance. In these situations, multiple ground rods can be installed and bonded together. The NEC specifies the minimum spacing between ground rods to ensure that they do not interfere with each other's effectiveness. The spacing between ground rods should be at least equal to the length of the rods. In addition to ground rods, other types of grounding electrodes can be used, such as ground plates, ground rings, and concrete encased electrodes. Ground plates are metal plates that are buried in the earth. Ground rings are conductors that encircle a building or structure and are buried in the earth. Concrete encased electrodes, also known as UFA grounds, are conductors that are embedded in concrete foundations or footings. The NEC allows the use of these alternative grounding electrodes under certain conditions. The selection of the appropriate type of grounding electrode depends on the specific application and the soil conditions. In areas with high soil resistivity, it may be necessary to use multiple grounding electrodes or to improve the soil conductivity. The NEC provides detailed guidelines for the design and installation of grounding systems. It is important to consult the NEC and to follow its requirements carefully to ensure that the grounding system is safe and effective. Grounding is not only important for safety, but also for the proper functioning of electrical equipment. A properly grounded system helps to reduce electrical noise and interference, which can improve the performance of sensitive electronic devices. Grounding also helps to protect equipment from damage caused by voltage surges and lightning strikes. In summary, grounding is a critical aspect of electrical safety and performance. It is essential to understand the principles of grounding and to follow the NEC requirements for the design and installation of grounding systems. The 6-foot minimum distance between a ground rod and a dwelling is an important safety measure that helps to prevent electrical hazards and to protect people and property. This distance ensures that fault currents are properly directed to ground, minimizing the risk of electric shock and fire. It also provides adequate space for inspection and maintenance of the grounding electrode system. When installing a ground rod, it is important to consider the soil conditions, the presence of underground utilities, and any local codes or regulations. In some cases, it may be necessary to consult with a qualified electrician or engineer to ensure that the grounding system is properly designed and installed. Remember, electrical work can be dangerous, so it is always best to hire a qualified professional to perform any electrical installations or repairs. If you are unsure about any aspect of electrical safety, consult with a licensed electrician.